Well, Python is a little bit of a challenge to integrate in with our thinking here. It tends to be um, kind of like math class in the sense that we have all of a sudden a textbook that is throwing 50 to 100 problems at us in terms of practice, and it's very similar to math in the sense that you need to go through a lot of the problems to develop the skill set. But at the same time, it's also kind of a lot different than math in the sense that with math you have a specific formula that you apply to solve repetitive problems, whereas when you're doing programming, you have uh, techniques that you use, but the actual solution that you devise, the equation, if you will, can vary dramatically depending on your approach to the problem. So it's like math in some sense and not like math in another. That probably doesn't help a whole lot, but what I want to do was go through some basic workflow issues, and let's kind of do a quick review of the material we covered where we talked about algorithms and flowcharts, because that's really where we started thinking about, the logic behind how to do programming. And I want to just, we'll go through this quick. A couple of thoughts again here. There's two typical tasks. You've got to do the problem solving bit. So when you're given a problem that you need to solve, you have to think it through and come up with some kind of a solution to it. And that needs to be in some sequence of ordered steps. So those steps are what we call the algorithm. Once you've got an algorithm developed, then you can shift into the coding phase. That's where you actually implement the program in some kind of code. Now we talked about the scenario of doing the pseudocode in kind of a natural English language. That's kind of useful in some scenarios, probably not so much for what we're doing right now, so I'm going to kind of skip by that for a minute. And let's get to the point where we're looking at the more detailed algorithm, because this is much, much closer to what you're doing when you're writing code. So it's a natural progression when you analyze a problem, come up with some detailed algorithm like this, and then quickly transition it into code. So here's a scenario where we're inputting 4 different variables. So this begins to look familiar after what we've studied with Python. Hey, I'm going to input 4 values, and we're going to put them into variables called M1, M2, and M3, and M4. Then we're going to take and we're going to, in step 2, we're going to do some mathematical expressions with those variables on the right-hand side, assigning the results of that expression to the left into a variable that we're going to declare called grade. We then move on and we do a simple if statement. If the grade is less than 50, then do some action. Print fail, otherwise print pass, and that's the end of it. So it's a very simple algorithm. And if we were going to implement that in Python, it would be a very simple thing to do, and we'll go through an example of that. So the flowchart, we talked about that, and for right now, the things that you're doing almost aren't really too worthy of a flowchart. I'm not going to spend much time on that, but again, it might help you to work out some of the logic behind your program. So here's another example with pseudocode, but we don't care about that. We're not going to skip past that, another algorithm, input a couple of variables, do some processing, and do the output, print the results. Now it's important that we understand the relational operators and the decision structures really before we can move forward. I know that's not until the next chapter, but in order to really be able to do any programming at all, you have to have some basic mastery of this concept. So we're going to go back and we're going to run through this real quick. A decision structure is an if-then statement. You're evaluating a condition as to whether or not it's true or false, and based on that action, you're going to do something. So here was one of the examples. Is A greater than B? Yes, branch to the left and do something. No, branch to the right and do something else. So the structure looks like this. This is just a generic if-then-else structure. If some condition, then do something, whatever the true alternative is, if that condition evaluates to true. Else, if it's not true, it has to be false, and therefore execute some subset of code for a false condition, and then end your if statement. So here was another quick example, A greater than B, do this, we just looked at that. And then here are your relational operators. These are the things that you're going to want to know how to work. Now these are the mathematical ones, so they differ just a tad bit from the ones in Python that are in the following chapter. But if you understand these and their basic function, you should have no trouble with this at all. All right, so here's another more detailed algorithm, which simply looks at a couple numbers and determines the largest one. And we're going to go through that in an example here in the text. So that's probably about all I really want to say. I guess the nested ifs, something else to keep in mind, because you'll end up having to do that sooner or later. Just keep in mind that it's an option. It's something you can do. You can nest things. All right, read a couple numbers. So here's a good example of some basic, detailed algorithm code. We could execute this in Python very simply. So why don't we shift gears here and let's turn our focus over to Python. If you start up Python, this is what you get. You get the interpreter. The interpreter, while useful for doing a few things like, basic math, you can execute things in here and say sum is equal to 4 plus 5, and then print sum. We could do without all that flashing down at the bottom of the screen there. The point is, it's not, although it has some merit, it's not any good for writing code. If you're going to write code, you need to get the editor going. So in order to do that, you're going to go up here to File, say File and New, and then you're going to open the editor. So the kind of workflow we need to do here is to set this up so that we have the editor on like the right hand side and the interpreter sitting over here on the left hand side. So we can arrange our screen so that we have these things up side by side. Now over here on the right, I can begin to actually write some code. The one thing I'm not terribly happy about this idle editor is the fact that it does not provide you with any line numbers, and line numbers are particularly useful when you're writing code. Now there is a way to get around that, and I'm going to cover that in a little bit later lesson, but for right now we're just going to drive on. So the workflow here is going to look like this. You're going to write code. So if we were to take the example that we were looking at here, let's take this thing and let's shrink that down a little bit. Get it over here where we can kind of take a look at it. If we were going to take and convert this into actual real code, thinking about what we've learned in Python, first thing is going to be to input our numeric values. So and there's different ways of doing that. I'm just going to bang this out real fast and say that num1 is equal to input, and we want to give a string. We have to prompt our operator. I wonder if I can stop that from flashing like that. Bear with me for a second here. This little fancy pointer thing I have going on is causing some strange results here. So input, all right, please. That's pathetic here. We're going to have to get rid of that. Goodbye. Please enter a number and finish off our quotes. Like so. So that's one number. Now if you recall over here we have three numbers that we actually want to bring in. So let's use our friend, actually let me fix that, I don't need that there. We'll do copy paste just to keep life simple here. Do that twice. We'll change the variables to num1, num2, and num3. That gives us a very simple piece of code, and then we could do a quick print statement to verify that this is actually working. Num2 and num3. So this is the first piece of our code. I would also like to encourage you to comment your codes, to document your code. So this is find the largest of three numbers. First up, get input from user. So here's a piece of code, and we're going to save that. We'll go File, Save As. Now, one of the annoying things about this Python editor is that it seems to default you into the Windows System 32 directory, which is a really bad choice. Why they've done that, I have no idea. But I'm going to maneuver over to the Python folder. Here, I'm just going to overwrite that file called myprog.py. Now I'm going to actually run the program. So what I'm going to do is go up here and run F5 is a shortcut to do that. And when it does that, it'll pop up over here in the interpreter. So I can begin to put my input in here. I can give a number of 5, another number of 8, and one of 2. So the print statement then prints out what those numbers are. So would it make sense then at some point we ought to be able to calculate a sum of those numbers, and I'm doing this to show you a particular point here. If I was going to say sum equal num1 plus num2 plus num3, and then print sum. And we're going to save that. I'm going to do a Control S to save it quickly this time. F5 to execute it again. We'll restart over here. Put the same numbers in, 5, 8, and 2. But notice that we don't actually get the sum of the numbers, which should be 15. It's printing out 582. Why? Well, that's because when I input the numbers back here, the default behavior, if you just do a straight input, is that it brings in strings. It brings in characters. So what it did was assign a character 5 into num1, a character 8, and a character 2. So when I printed those, it just printed them one after another. And what we would have, if you recall, we called concatenation. It just strung them all together. Well, that's obviously not what we were trying to do, because we actually want to use the numbers to numeric, and we want them to be integers. So the way you fix that is using the eval statement or function. You put eval in front of this whole thing, like so. In this case, when we do that, it will then return a numeric value that we can actually do some math on. So if I do that, and again I do a Control S to save those changes, F5 to run it again, put the same numbers in, 5 and 8 and 2. Now this time it actually does the math for us like we want it. So keep in mind as you're going through and doing this, the tendency of Python when you input things to treat them as strings. So you have to make some additional effort if you want to treat stuff as a number. All right, so you can begin to see the workflow here as I write some code over in the editor and save it and then run it. It shows up over in the interpreter. Now let's take a quick look at where we're at here with our samples. So I'm going to back this stuff out of here because it's going to be irrelevant. I just wanted to prove a point there. So we're going to move on, and here's where we're going to introduce our decision statement. We're going to say if, and the syntax is a little different with Python. You don't need the parens. Most programming languages you do, but for Python it's much looser than that. So it's going to say if num1 is greater than num2. Don't need a then. What we need is a colon. That drops us down to the next line. And oh, this is a nested if statement, isn't it? So we're going to start another one. We're going to say if if num1 is greater than num3, then we'll call it big num is equal to num1. Else big num is equal to num3. I suppose for appearance's sake we might want to do this. Now I need to back up here to get in the proper indentation, keep my if then else's lined up here. So the next part of it is if num2 greater than num3, then big num equal num2, else big num equal num3. And in Python so far we haven't really gotten to any kind of end ifs. Let's just do this. We'll just see if this works out all right, and we'll do a print statement. Oops. Print the largest number is. Remember, it automatically puts in a space for us when we use the separate values. So big num would be the proper answer because that's the variable that we put everything in. So that's it. Now we've taken and coded our detailed algorithm into Python. Now let's save it with Control S and F5, and let's see if it runs like we think it will. So we have 5, and we have 8, and we have 2, and it comes back and tells us the largest number is 8, which is correct. So that's an example of how to quickly convert some detailed algorithm that you might pull together just without a whole lot of effort into some Python code. Now while we're at it here, I just want to show you another thing too. While you're working like this, the editor, or not the editor, but the interpreter can be used to actually tweak your code a little bit. So everything is actually still loaded over here. So I can actually do things over here as well if I wanted to print num2, for instance. I can still go over here and actually test some of the values that are in my code interactively. That can be useful from time to time as well. So that kind of summarizes this real quick lesson of how to use Python to the idle editor to write code in the editor and then execute it over here in the interpreter. Now there are other ways to do this. You can use Notepad++ and then save the files and run them from the command line as well. I'll show you that in a different little screenshot video cast here. So that's it for this session.